And for our final lesson on loops, we're going to look at the second type of loop, which is called a conditional loop. Oops. That was a little loud. So what are our objectives today? Today we're going to create loops that end based on a condition rather than a count. We're going to compare conditional loops to other control structures. But before we do that, let's see what Chris Bosch has to say about conditional loops.
Every athlete knows that you get good by practicing, by repeating the same moves until you get really good, or until you reach your goal. When I was in high school, I wouldn't leave practice until I made 10 free throws in a row. Similarly, when you get to a computer program and repeat a command, you can give it an exact number of times to repeat. Or you can define a goal and tell it to repeat the command until it reaches some goal.
Thanks, Chris. Thanks, Chris. Combine Chris and Chris Bosch there. So obviously, he gave us a little introduction about what we're doing today. We're going to repeat some action until some test condition is no longer true. So what does that actually mean for us? Well, a conditional loop is a loop that continues to loop until the test condition is no longer true. Now, we talked about a number of pieces there that we've mentioned before, which is the conditional loop is still made up of the same three parts that made up a for loop: the comparison variable, the test condition, and the change. They're just going to look quite a bit different this time and be organized a little bit differently, but they're still there and they're still familiar. So the most common type of conditional loop is the while loop. And the syntax for a while loop is almost identical to a simple if statement. So much so that I'm going to teach it to you by comparing the two. So let's compare the two. We have if on the left, a simple if statement on the left, and we have a while statement on the right. Now imagine I've created this program where I have an integer called num, and I'm going to ask the user for a positive number. Pretty straightforward here. Enter a positive number, num equals convert.toInt. So whatever they typed in, that's great. Now on the left-hand side, in the simple if statement, I'm going to say, well, what if they didn't enter a positive number? I'm going to say, if the number was less than 1, then I'm going to give them another chance. I'm going to say, your number was too low. Enter a positive number again, please, and read that number in. And then it will continue on with the rest of the program. Now let's go over to the while side for a second. We're still asking for a positive number, and we read in that number. Now what if they enter a number that is too big? Sorry, too small, I should say. Not too big, too small. While the number is less than 1, we're going to tell them it's too low, and we're going to ask them for another number. The exact same 2 lines of code as before. Then we're going to continue on with the rest of the program. So what is the one difference in syntax here? Well, it's that one word. The entire programs are 100% identical except for that one word. If was changed to while. Well, how does that one word make a difference? What is the logical difference here? Well, on the left, we're saying if the number is less than 1, so if the number is negative, give them one more chance. But once that one chance is done, that's it. The program continues. That's it. On the right-hand side, it says keep giving them another chance. Do it forever, absolutely forever, until the user gets it right. There's your big difference there. So if says if it's less than 1, give them one more shot. And on the right, it says while it's less than 1, continue giving them another shot, and continue and continue and continue. Now, all 3 of the parts of a loop are listed here, but let's show you that just to make sure we know where they are. So here's the exact same program. Nothing has changed. Now, if you remember our 3 parts were the comparison variable, the test condition, and the change. Now, let's find all those pieces. Where is the comparison variable? What is the variable that's being compared? Well, that's that number variable. And not only are we defining it there, we're also giving it a starting value, just like we did in a for loop. In the for loop, it was int I equals whatever. Int I equals 1, int I equals 0, whatever it is. And here we're saying create the variable and let the user enter the number. We don't care what it is. It doesn't really matter. So that sets up the comparison. The next thing we need to do is we need to test that comparison variable. We need to go to the test condition. Well, where's that? Well, there's that test condition right there inside the while loop. While num is less than 1. Okay. If that test is true, if that evaluates to a true, it's going to enter the loop and it's going to execute all the code within. Code to execute if the test condition is true. All 3 lines from top to bottom. But that leads us into step 4. Step 4 was the change. Change the comparison variable towards the target value. In this case, the only way we can do that is by asking them for a new number. It's not counting, it's not progressing, it's just simply modifying the value. Eventually, we hope the user will enter a number that's correct. Can we guarantee it? Absolutely not. We cannot. That user can be entering negative numbers until the cows come home. We don't know. But we do know that we're giving it the opportunity to change. So it's gonna get a new value from the user. And then when it's got that new value, well, it's got to test that new value. So it goes back up to the test condition. It goes back up to number 2. And it says, is the new value less than 1? If so, go back in the loop. So we get that loop again. 4, 2, 3. 4, 2, 3. 4, 2, 3. And it continues that whole process over and over and over again. Eventually, hopefully, the user will enter a number that's positive. When that happens, it fails the test condition, so the test condition is false, and it will continue on with the rest of the program, and it moves down to number 5. The test condition is false, continue with the rest of the program. So we can see that this is the exact same structure as the for loop, and in fact, I literally copy and pasted the slide, and I just changed the code. That was it. Everything else is identical. All right, so let's go on to the next piece. So now we know what a while loop looks like. It's just an if statement and change the word if to while. But what else can we do with that? Well, one other feature that we can do with all kinds of loops, not just while loops, but all kinds of loops, sometimes there's a scenario where we need to exit the loop early. Sometimes it may be necessary. It happens. For example, if your algorithm finds its result early and it's not necessary to continue analyzing the rest of the data, get out. There's no point in wasting the CPU to continue that. If you found your answer, stop working. So that's a time when we may need to exit a loop early. So how do we do this? To do this, we're going to use a keyword that we've already used before when we learned switch statements, break. And if you remember what break did with switch statements, it broke out of the switch. It broke out of the control structure and continued on with the rest of the program. It's the exact same thing here. Break breaks out of the current control structure it's in and then continues on. So let's break this down. Pardon the pun. Break. In a loop instructs the program to immediately quit the current iteration and go to the first statement after the loop. What about if you're in a nested loop? If you're inside an inner loop and you hit a break statement, it breaks out of the inner loop, not the outer loop, only the inner loop. So you got to be conscious of this if you are using nesting. Next big point. Obviously, the break statement must be inside a selection statement, either an if, an else if, or an else, or a switch. Why? Because if it's not, that just means it's going to get executed every single time, and your loop is no longer a loop anymore because it will stop looping as soon as it hits the break statement. So there has to be a chance that it won't break, right? So that is exiting out of a loop. So let's show this. What does this actually look like? So here's your typical password program. I've defined a variable called numTries, which starts at 3. A password, which is secret, and some input that the user is going to enter in later on. And I say keep looping as long as numTries is greater than 0. So 3, 2, 1. Okay. Inside the loop, what are we doing? Well, we're going to ask them for their password. If they get the password correct, we're going to say access granted and break. Otherwise, if they got it wrong, we're going to say access denied, and we're going to reduce our numTries variable. So now numTries goes down to 2. If they get it wrong again, it's going to go down to 1. If they get it wrong again, it's going to go down to 0. And then it's not going to get in the loop anymore. So what 2 things can happen to cause this loop to end? What do you think it is? Well, the first thing is, as soon as they get it right, it's going to hit this break statement, which means it's going to jump out and continue on with the rest of the program. It's not going to do anything else. It's immediately going to break out of the while loop. Okay. What's the other thing? Well, the other thing is we can simply just run out of tries. Because if this test condition fails, if numTries reaches 0, 3, 2, 1, 0, that means we've used all 3 tries. We can't get in anymore. So it continues on with the rest of the program and skips the logic. So there are two ways to exit our program. Now, you should probably be using those break statements very sparingly. Now, I use this analogy all the time. Break when you need to, not when you want to. Okay, what that means is the equivalent of breaking out of something, it's very harsh. You should try and do things elegantly so the program naturally goes through the sequence and gets through things. Now, why does this matter? So imagine this. If you want to shut down your computer, normally you're going to hit the Windows key, you're going to go to shutdown, you're going to let it peacefully shut down because you want to make sure it saves any settings and things like that so everything works the way expected. Is that the only way to shut down your computer? Nope. You can walk over to the wall and pull the power out of the wall. It does the exact same thing. Exact same thing, except it doesn't do it gracefully, which means all that data that you had is just gone. So what I'm saying here is, yes, break will work, but it's harsh. But if it makes sense, use it. I'm not saying not use it. I'm saying use it when it's necessary, not when you just want to stop a loop. That means if you are using it too frequently, chances are your test condition is not good. You need to reevaluate what you're testing. Now, this test condition doesn't have to be just one test. You can use a compound statement here. You could say while num tries is greater than 0 and something else, or something else. You can do whatever you want as long as whatever's in those brackets evaluates to a true or a false. You could even say while true. Whoa, what? Yeah, you could just literally have the literal value true inside there, while true. Now, if that's the case, you have what's called an infinite loop. It will loop forever. The only way to stop that loop is with a break statement. Now, there are definitely circumstances where you may want to do this. But again, do so cautiously and make sure that your loops make sense to do that. So that's everything we're going to learn about loops for now. Going forward, we only have a few things left in the class, and then that's it. It's on to project season. Good luck with everything, guys.